Let's see the next question in this exercise, question 13 to 2. The following data gives the information on the observed lifetime in hours of 225 electrical components. Determine the modal lifetimes of the components. We are supposed to find out the mode of the given data. And the given data is in terms of lifetime, which is in hours, and the frequency is also given. Uh, the 10 electrical components out of these 225, they have a life of uh, between 0 to 20 hours. 35 such components have lifetime between 20 to 40 hours and so on. Now, um, if you notice the frequency, first of all, mode is the observation which occurs the most number of times. Uh, if you see the frequency column, this 61 is the highest frequency. So that means your mode is anywhere between 60 to 80. Now, where exactly is it? Well, we have a formula and we are going to use that one. So first step in finding out mode, since mode is the highest occurring observation, find out the frequency which is the largest. So your mode will be somewhere in between 60 to 80 hours. Now, if you look at the formula given in the textbook is exactly same. However, I took the liberty to modify it. Here in the denominator, the formula is 2f1 minus f0 minus f2. So if you notice that this formula and what is given in the textbook is exactly identical, there is a reason why I'm modifying this formula a little bit. Let us see first the terminology. L is the lower limit of the class interval in which the highest frequency is occurring. So if the class interval is 60 to 80, the lower of that one will be L, which is 60. F1, F0, F2 are the frequency of the three class intervals, one of the class interval which we have just highlighted right now, one previous to that, and one next to that. So F1 is 61 here, F0 is one previous to that, and F2 will be immediately after that. So now it's a matter of finding out differences. F1 minus F0 will be 61 minus 52, that would be 9. So that will go to the numerator and it will also go into one of the terms in the denominator too. F1 minus F2. Remember, F1 is going to be superior as compared to the two adjacent because F1 is always largest. F1 is always largest because that we have chosen F1 such that the mode will be in that. So F1 will be always higher compared to F0 and F2. So F1 minus F2 will be in this case 23. Right? Remember, all these brackets are going to be positive. Now, in the formula which is mentioned in the textbook mentions 2f1 minus f0 minus f2. I prefer this way because that gives you more intuition what exactly we are doing. We are actually finding out the differences in frequencies compared to the previous one and compared to the next class interval. And h is the width of the class interval. Well, all the class intervals are of width 20. So h is 20. Right? Let us substitute the values. L is 60. F1 minus F0 is F1 minus F0 compared to the previous one. That's 9. F1 minus F0, again, same thing, 9 plus 23. That's the next one. And the class width is 20. It's a matter of substitution. 9 divided by 32 times 20. So that would be 9 divided by 8. Let's cancel the common factor 4. And upon simplification, it comes out to be 45 divided by 8, which further can be simplified to 5.625. So your answer will be 65.625 hours. And that's the mode of the given data. And that would be your final answer.